Okay, so we put the plate in. So the first thing that you want to do after you put your plate in is select New on the left. If you were going to image a similar format plate as the one that you imaged this time, you can select the three dots, and this will bring you, select your username, and then this will bring you to your prior experiments. So you could actually click on one of these prior experiments, and all of the settings that you used for the past experiments will show up again. And then you can go from there. But for this one, we're going to go New. Okay, so the first thing you want to do is, if you would log in normally under your username, but just that your plate is under your username, I just created one for you, and it's the first letter of your first name and then your last name, and your password is the exact same thing as your username. Your username basically just saves all of your information underneath your folder. So anybody can access anybody else's information, but it will save everything under your account basically. Okay, so this is all reset. So basically you're going to start with your plate type. I'm pretty sure your plate is going to be the 96 grainer plastic bottom. This correction color, I don't typically adjust. If you're having focus issues, then you can adjust it, but I usually say no. 2 peak is the default. If you right click, you need something else, you can go to help. I'm going to do 20x water. That's my favorite objective. Console full. Bidding, the default is 2. If you needed bidding of 1, you can set that up. So you have a GFP stain. So if you hit the plus sign, there should be GFP in here. There's not. Pretty sure GFP is Alexa 488, but I'm just going to double check. Okay, so GFP is excited by 488, so I'm going to change it to 488. On the left, you have your time, you have your power, and then you have your height. The first thing that I do is I select a random well. It doesn't matter so much right now. And then select the middle box. And I'm just going to do a test. The first test that you do is going to take a couple extra minutes, just because it's requiring image alignment parameters. So down the bottom here is the messages tab. If there's any errors show up, if you right click on the plus or the down facing arrow here, help bring you to the manual, the little question, and then this other, if you open all of this up and send me a screenshot of this, if there's any errors, then from there I can help you figure out what the errors are, and if we need to, I can send that error code to PerkinElmer, and they will send help. So this has some issues finding the image alignment. So if that happens again, I might have the wrong plate This is basically trying to find the bottom of your plate. So while this is trying to image, on the right here, there's two tabs, Define Layout and Test Images. Once you hit Test, you want to go to Test Images, and this shows you the well that you selected as well as the field that you selected. So there was a focus failure. So basically, this is trying to tell us that the height is wrong. So if you click the little help thing, it has typically, this is because the wrong plate was selected. There's a whole list of things there. Let's try different plate. Try this one. Okay, so now we got this one to work. So we'll leave this as the grainer stencil plate, as likely to be the one that you're using. Okay, so this is just imaging at your 2 microns. The first thing that I do after, so this is showing that with this layout, we can't use your positive or negative control. So let's try. Uh-oh. We can get it to work with this one. Just select a different well at random. Focus failure as well. Okay, so it does seem like your plate, we can't image the left and we can't image the right cells. And the bottom ones have a restriction above 818 micrometers, which is fine. So basically for this one, if you can, you want to fix the inside. These top and bottom ones, if they image fine, you should be all set. But your negative and positive isn't going to work. So the first thing I do is I go down here to the layout selection and I do a Z-stack. I do -10 microns, and I do 30 planes, and I do these 1 micron apart. So this is going to determine your height, your fast looking height, and that's going to go here. So again, it's selected random well, and I kind of like move it around just so that I don't want to reach the same well. And I'm going to hit test again. And then once I hit test, I'm going to go over to the test images tab and click on this, and if you make the plate orange, the field orange, and as these turn blue. So what I'm looking at is intensity. So if you right click, show intensity, you can put it on where one of your cells is, and then you want to find the Z height where the intensity is the highest. You can kind of tell which one looks the best. So for this cell, it's going to be 5. Check one over here. This is 8. Check 1. The highest one is at 8 here as well. Okay, 10. Seems to be at different heights. Again. Now go to a different well, and I'm going to select a second square, maybe a third square, just to see the variation across the plate or across the well. So this is going to image these 3. So again, go to test images, make this orange, orange, and then as it starts imaging, it's going to turn blue. Up here, check plate intensity. This is pretty consistent, but this one's the highest is at 6. One down here. This one's at 7. This one has either 8 or 6. You go over here. And then it's called 9. This is really ugly right now because the intensity is really low. This one's at 7. It's kind of all range between 5 and 10. So I like to have my intensity between 2,000 and 3,000. So I'm going to increase this to 100% power. And then I'm going to take another well, and I'm going to test that as well. So I test images. This one seems to be kind of random, but we're going to call it 7. So the intensity is still really low. It's very different than the background, but some of these areas where it looks like it's in cell is pretty close to the background. So I'm going to increase this to 200 milliseconds. Again, taking it as well. So ideally, you'd be able to check this in your positive and your negative, so that you see the highest and you see the lowest. I don't have those, so I'm just going to randomly select different wells and hope for the best. Okay. So as you can see, these intensities are higher. Ideally, you want all of the intensities to be higher than 2000. And I pretty much narrowed it down to all of mine are between 5 and 10. So I can actually go next test to use 90 height. I don't need all of these. And then and if you use a scroll on your mouse pad, or you can hit zoom, and then zoom to fit, that'll bring you back to third one. So as you can see, this is starting to look better as we increase the time. Some of these are still dim, but the most important part is that significantly different than your background. So your background's all like less than like 230 or so. So as long as these are significantly different, your software is going to be able to pick them up and detect them. Because you have to balance time, so if you are in time, the question is, do you want to increase your time to image in order to get a higher intensity or not? Something tells me that there's going to be a lot of background here. There's a lot of these smaller things that aren't cells. But there's size cutoffs that you can It does seem like the higher you go, the less background there is. Maybe change there. As the higher I go, the less background there is. I really want it to be in the middle of your cells. And do another test. one Z, and it's going to be good across the whole plate. And if you hold control, you can look at multiple cells. Okay, so kind of see as I'm going through the Z happening. The intensity is changing with your Z, and so where I initially thought was the highest, and that's where the highest, there seems to be like two kind of peaks. You kind of just want to pick one that has the biggest area. I think what I'm going to do is I'm going to image some couple wells at a couple different Z heights for you so that you can play with them. So I'll do serotonin. So I'll randomly select three wells. The other important part is the overlap, especially for 2D. Overlap is going to be changes where these fields are. So I'm going to change this every 2 microns. I'm going to go 6 microns to 14 microns. So go to 16 microns. It's going to take 10 minutes to image. So whenever I start an experiment, so when you're in the setup tab, that's when you come up with the program and come up with all of your settings. You want to hit save before you start going, and then you go to run experiment, and whatever settings you had in setup will be imaged. So I selected for you 3 wells, pretty much the entire area of the well, and I have my 6 places. And I always sit here until it starts imaging just to make sure. So while this is running, I'm just going to quickly show you. So you can kind of see what your cells are doing. So they're all kind of there. But like especially this one down here, it's really easy to see that it's kind of there, but then it's kind of just part of your cell. So if you decide that you need to do multiple D types to get so that you can look at your image analysis for individual planes, or you can do max projections. The max projection is going to combine all of your Ds, and it's kind of sandwich it down so you get all of your Ds. And again, you can see that it's different, significantly different than your background. It should be fine for image analysis. So flat fill correction, if you have basic or advanced options, you can select those. And I can do add building blocks. So for here, if you want to find your cells, there's basically different methods. So if you right-click help, it just shows you what method is kind of generally best for what. It doesn't always work out perfectly like that. So I always just kind of play and I go, okay, do I like how that one looks? And if you right-click, you can tune parameter. And so you can hover over each one to kind of decide, like, okay, P terrible. I just want to pick one that best distinguishes your cells. You see that M is kind of splitting them. A, B, or C isn't really detecting all of them. So kind of pick the one that looks overall to be the best. So I can select C here. Oh, the other thing, if you click on the image analysis one, it will tell you how many text space. I'm actually tell you on this one. You have to have that, and then you can see that it's detecting 71 objects for C. A is giving you 51. B is giving you 80. As you can see, there's some that are detecting it as multiple images. You can go and save. There is 2 drop-down arrows. So you can, again, right-click change parameter. And this is going to say this one's fast. Again, you can hover, you can scan, and that will add more. You can hover over each one and decide which one looks best. This one is selecting more than the other one. So it's okay. area, so if you right click and highlight object, you click on one, this is going to give you the area, or you can go here, and so this has a cutoff of 100, and you just click all the way at the top, all the way to the right. This has cutoff of 100, so you can select one, and you can decide, like, what, are you happy with these ones that are 100? Are they mostly background? Are they actually yourself? You can even drop this down lower. Oh, so you select the area and then hit apply on the bottom, and then it'll bring you. So now I can look at the ones that are 50 microns. So like right here is one that's 50. So I would say, okay, so 50 is background or improperly detected ones. You can kind of go through these and say, well, those aren't really cells, they're mostly backgrounds or improperly sized ones. So I would probably stick with 100 for this. Splitting coefficient, again, you can tune parameters. You can see that if you select one of these higher ones, it's actually picking up more of your cells. So you can say, you can determine, think that it's accurately enough to select the cells here, or if you want to go up here. I'm going to stick with right here for now. So basically, you can keep going, and you can pick contrast, whatever is good. Again, right-click helps, and it will go through everything for you. The next thing you can do is morphology properties, so you can cut off. So say that this line isn't, it really kind of due to the sphericity or the roundness. It'd be kind of like these lines versus these circles versus kind of like blobby things. We have different ones. Width, height, and length, the ratio of the two. So this, let me just show you some samples. So if I click on this one, apply. Okay, so if I want to cut off these ones that weren't cells that were really long, you can kind of like write down, click on what these are. You just want to be careful because like this one is a cell, for example. So this width, for example, is 3. This one is 26. This one has a width of 8. So then the next thing that you can do, and you can also do the intensity. So each of these is going to have an intensity. So you can organize these by highest to lowest. And decide, okay, this isn't really a cell at this intensity. And you can do different thresholds. Now if you go to select population, then here you can say, okay, so the width, if it's less than 10 microns, or you want it to be greater, there you go. You want it to be greater than 10 microns, for example. And there is scatter plots and histograms that can help you detect. So this, you can see where the bulk of your spheroid or your cells are, so you can do cutoff based on that. And for roundness, so you can decide what you want to do. If you want your intensities to be above these ones that have lower intensities, you can say, well, these are kind of more background. So you can say, I want my intensity to be above 500. That will show you. Here you go. So here's the one. It's different graphs. You kind of see where everything is, and you can make, based on what you want to find, you can make all kinds of limitations here. Or if you want to segregate two different populations, you select this population, call this population A, call the next one, and then do next population, do population B, and you can have two different populations. So then say that we did our cutoff, so now, and you want to follow the name, so up here it's cells, and then this is cells selected. You have your cells here, and then you have your cells selected. The other thing that is good to do is to select population again, and then your cells selected, and then you want to do any ones that's on the border, so there's only partial cells. You just want to remove those border ones. So down here, so these are cells selected. I suggest saving them so they make more sense. If you want how many objects there are, and you want to export the mean intensity, for example, you can do all of these or any of these. And then if you want to export an Excel file, so this summary down here is kind of what your list of outputs up here would look like. If you want this with all of the information for every single spheroid, then you want an Excel spreadsheet like this with every single object. So these are called objects. You just do object results, and then your cells selected, and then you can do all. It will have all of the properties that you copied, or only use selected raw results. So selected raw results would only give you the intensity. So that's like a quick run through of this. This takes fine tuning, and this is going to depend on how everything looks across the board. So you want to look at multiple wells as well here to make sure that you're happy with how it looks. So on the right here, you can select to turn things on and off. You can see that some of these are beautifully identifying your cells, and some of them are not so much. Like this one that's identified here isn't on a cell. So you can do some intensity or side cut off just to get the ones that you want. And also keep in mind that there are 3 views: standard, enhanced, and highlight. And I can show you that the intensity does not change, but what you're physically looking at on the screen will. If you right-click Save Image, this would be what gets exported, exactly what you see on the screen. If you export the raw images, then that will have the intensity calculated, or it shows you. I've never actually done that, so that will have the raw image with the intensity. And so again, you can see here that this just plays the min, max, gamma, and the max. And you can play with these by hand too. So when you're trying to determine, like, you can kind of remove some of the background here, where you're trying to decide what sells, what's not. So basically, you just want to kind of like really play with things until you're happy with how things look. So now, I go back to my setup. Now I want to image across the whole plate for you, and I want to try to pick one V that's going to look good. So if you select all of these, right-click, and do Plate in Well Realistic, you can get the entire well. If you do your flat field correction, you'll see that makes those kind of like grid lines go away. And then there's also stitching. This will help make it look a little cleaner as well. You can label this image. You can right-click, save this image, and you can play with again the different settings here as well. If you want to look at these three, I'm going to do plate hat, well realistic. So that's going to show you your three wells to compare. So your cells are like, other than like right here, your cells are pretty evenly dispersed. Is always a good thing. And again, you can use zoom to fit, you can zoom in, you can zoom out, zoom to fit, or set 1-to-1. You can right click save. You can do any of that kind of stuff. So here is where I kind of look at my positives and my negatives to decide what I'm going to do. I want to take a different Z. I can do that. The other thing that I can do if I want to look at different Z's, I'm going to do it just for one. You can do stack. You can only do it on one well, one field. Do a stack, and that's just going to take each of the Z's and line them up. If you want to know which one's which, you can put small labels on. So this is G6 is the well, P2 is the plane, so this is the first, second, third, fifth is 6. Z. You can kind of decide. I'm leaning towards imaging one of these higher planes for you, just to get rid of some of this background staining. And I'm going to look at that for one of the other wells. Side. I think I like this one best. Okay, I think I'm going to go P4. What was the fourth one? So 10 microns. I think I'm going to go 10. Finally. Okay, I'm just going to go to P4 and call it good. So, I was actually 12. Oh my god. I'm just going to check that my intensities are pretty good. Sometimes I like enhance, so I can kind of like click on the object in the background just to see what the difference is. A normal confocal, this white kind of means overexposed, but that's why I look at the intensity and I see that it's not perfectly fine what the intensity is. Okay, so we are going to hit reset here because I don't only want one C height. I'm going to go with 12 microns. I keep the time at 3 microseconds, 100%. I'm going to keep the 3% overlap. So it looks like on this particular plate, you're back not to image any of the outside wells. Maybe that's because I have this here. Okay. Okay, so I can get this bottom row image type left. Let's do well. Do anything in this row. So I'm going to say that your cells are evenly distributed across your wells. Just to get this row image for you for this experiment, I'm going to say that I'm going to do just this inner part of the well. So as soon as I select anything outside of this box, it's going to cut off that well. You can also do field centered. Let's see if I do that. Okay, so I can do 49 there, so I can get a little bit more. Okay, so let's do that. And again, this comes down to time, how much time you want it image within. This is 1 hour, 9 minutes. So for this experiment, I'm going to do that. So I'm going to hit save. So I'm just going to put the date. All of this information here, it stays connected to your plate. You can do comments. You can do anything that you want. I like putting it as a date and then kind of like a label of what specifically this plate is. So when I go back, I have that. Next time, if you're going to run a plate and you're going to kind of start at the same plate, you can click on the 3 dots and you can see that experiment. You can see the user, you can see the plate selected, the channel, emissions, expectation, there's a 20x water. So all of this information is saved for you. You hit OK. Now, if you're happy with everything here, you can go here to run. This is the experiment that you just saved. If you were going to have an assay layout, you would add that here. And just so you know, if you ever did want to make one, you can go settings, assay layout editor, and then you can add subtract different tabs, whatever you want to save, and then you can save that. I didn't see anything, so I'm going to hit no. The plate was live. I should have CO2 and temperature on. I should have done that at the very beginning. It should just turn on at the tank. So turn on the CO2 main valve on the top of the CO2 tank. So I'm going to hit OK there. And yeah, so that looks good. I'm going to call this 5. This is just telling you that your temperature hasn't been reached. You won't start anyways yet. Ideally, you come over here and you could turn it on. As soon as you sit down, you turn on the temperature and the CO2. Okay, so One other thing that's important if you are going to go between water and air is ideally you want to wipe off the bottom of your plate before you start running your experiment. I did too. You just eject it, wipe down the bottom of your plate, and then put it back in. Do that real quick. So while I have your plate out, I'm going to cover it real quick. So if I'm going to load the plate. Other thing that you want to do, especially if you have any focus failure issues, is if you go to settings, for Phoenix, flush the water objective. This is always a good thing to do before you start imaging the plate. Ideally, you do it at the beginning. It's been a while since I've consistently used this machine, so I forget these little nitty-gritty details. But just if you flush the water objective, it just gets everything, all the water flowing. It will help you have less focus failure issues. Okay, so now I'm going to do that. Now I'm going to put some plates back in. Okay, so I'll load my plate. Okay, so I'm going to do all the same thing. And now I'm going to hit start. So I always sit here. So the way this image is, it goes up, down, into your plate. So this started up here. So here's a well. Here's the middle that there's a pipe yourself here. So then again, I can right click and look at the well as a whole. This will also show you how. So this well, they're kind of more concentrated in the middle and less dispersed. But I always sit here and I wait until I make sure that this is imaging fine. It looks to be going ahead fine. So now I'm going to sign off and let this run.